So recently, there has been a shifting trend in the open source community, especially for the AI models. So previously, more focus was on the paid services like ChatGPT, but recently, with the availability of open source models like DeepSeek, Mistral, Llama version 3, and Qwen 2.5, more people are more shifting to these open source self-hosting alternatives, which in some benchmarks are more powerful than the existing models. So in this video, I will actually show them that how you can manually run these models locally into your laptop. Whether you have a GPU or you just have enough RAM, you can run these models. And then we will actually test and compare the different models' performance, especially with respect to Google Earth Engine. Like, can these models generate Google Earth Engine related code? Or if we provide them some code, will they be able to debug it or can understand them? So we will see in this video. So first, let's talk about the requirements for running models. So basically, the requirements fall into three categories. First, we have the category in which you have GPU in your laptop or computer. So if you have the GPU, the models will run more faster and will generate more token per seconds. This means the output from the models will be smooth and you will be easily get the results as soon as you press enter and give your prompt. um, second case, you might need enough RAM to fit the model into your RAM, so the computer can process them and then you will get the results. So in this category, you can still run the model, but now you need to make sure the model fits into your RAM and the output will actually be slow. And lastly, if you have just the RAM and does not have the GPU, you can still run some models, but at the expense of the performance. So the model will not be very fast. So let's actually start with how you can run the model. So in order to run the model, the easiest found is using LM Studio. So all you have to do is you go to their website, lmstudio.ai, and here, based on your hardware, like if you are using a Mac, Windows, or a Linux distribution, you can select your OS and then download their setup. Once you have downloaded, all you have to do is just run, and the process will be automatic, like you will install it into your computer. So once you have downloaded and installed the application, you can just navigate and search for LM Studio, and once you open for the first time, you will see this window, something like this. So I will actually show you some settings that you can set right away and you will get a better performance from your hardware. So first, go to here at the bottom and select the power user. This will actually open some more menus for you to configure. Next, you want to go to discover, and here you can see three menus: model search, runtimes, and hardware. So we will get back to model search later, but first you need to go to the runtimes. And in runtimes, you need to make sure that everything is latest version and the build is select to stable. And here you need to make sure that based on your hardware, you have selected the appropriate version. For example, I'm using a laptop in which there is a RTX 3070 NVIDIA GPU. So in order to work with the NVIDIA GPU, you need to install CUDA toolkit into your OS as well as the NVIDIA drivers. So once you have installed those, you will get this CUDA as the latest version and it is running. So you need to go here and select the CUDA. So this means that the LM Studio will actually use your graphic card to run the model. Similarly, if you are not using any GPU and you want to run just on your CPU and RAM combination, by default, this will be selected to this CPU LLMA.cpp option. So just you need to make sure that this version is based on your hardware. And once you have selected the appropriate option here, you need to go to your hardware section. And here in this menu, by default, it will be selected to strict. You need to change it to relaxed or off. In my case, I go to off. So this means that if I load a very big model into LM Studio, it will still try to load it and will actually give errors if it is not loaded. But if you select something like strict or balanced, the model will not be able to even load it initially. So just click off and proceed. Now, one thing you need to make sure is the RAM and VRAM combination. So VRAM or virtual RAM is your graphic card memory. So I'm using a RTX 3070, which has 8 GB of GPU memory, and my laptop has around 40 gigabytes of RAM. Now, if I want to run models fast, I need to make sure that all the models fit into my graphic card memory, which is 8 GB. So I would focus on the models which are less than 8 GB to be able to run them faster. But if the models are greater than 8 GB, then I need to make sure the models are at least less than 48 GB so they can work with my RAM and graphic memory combination. Still, if you want to run models which are more than your RAM and graphic card memory, the LM Studio will still be able to load them with minimum layers, but the performance will be very slow. Once you have done this, you will see your GPU in the right panel. Here by default, it has identified my GPU. So once you have applied all the settings, you need to download some models to run locally. One of the best things about LM Studio is you don't need to manually search, download, and then import the models. They will be automatically downloaded and loaded within the application. But first, let's see some of the available models online. So recently, we have been seeing an increasing trend in DeepSeek because of its open source nature and because of its proven results compared to the existing models, which you can see right here, compared to the Qwen 2.5, Llama 3.1, and ChatGPT 4.0. So you just need to see the models, see their names, and then we will just search them into LM Studio. Similarly, some other models like we see here, Qwen 2.5, you can search their website or GitHub repository, can check their information. So here we can actually see that the Qwen 2.5 and also the DeepSeek is available in Llama, which is another tool to run AI LLM models locally. But we will focus on LM Studio because of its robust results and the ability to run larger models using both our RAM and GPU at the same time. So yeah, this is was just a brief introduction. So now we will move back to our LM Studio session. And here, in order to download the model, just go to this discover icon. And here you can by default see a list of the models that are available provided by the LM Studio community. Now you can easily search some model by their keyword like DeepSeek, and you will see all the DeepSeek models provided by different vendors available here. So in order to download the model, all you have to do is just click on any model and you can choose a quantized version. So this is actually like the quality. So the lowest model will be least in size, but will have the lowest quality. So if you want a good quality for the model, you actually have to select the Q8, which is the higher quality model, but obviously it will have a higher file size and will require much more computation than the previous one. So yeah, this was a brief introduction how you can download the model. And once you have selected your appropriate model, just click on download and it will be downloaded into your LM Studio, into your local directory. So on a side note, I actually will prefer you, if you have a low-end computer, that you download model from Onslaught, because these models are modified to work on low-end computers. They require lesser computation and they are in performance a little better than the existing model. So for example, if you type Onslaught, you will see all the models that are provided by this Onslaught. You can also go to their website and you can navigate different models which are available by Onslaught. So for example, the DeepSeek R1 version with 1.58 bit is available. And here actually you can see that the original model was around 720 GB and the modified version from Onslaught is available in just 130 GB, which is approximately 80% reduction in the file size. Similarly, here we can see that the DeepSeek R1, which is the recently more trending model, is available here. But obviously it is 140 GB and our hardware will not be able to run this model. So we'll see the different versions of the R1 model which are available. So here the second option, we see that this is 8 billion parameter model of the same DeepSeek R1 model. So we will download this for our testing. So here you can see I have already downloaded this model for the testing purpose. Similarly, you can search some other models for your use case. Here we can see that 32 billion is also available, but obviously it will require around 20 GB. I have also downloaded these models in advance to test them. Beside DeepSeek, we will see the performance of some other models that, like Qwen 2.5. So Qwen 2.5 is also available in different parameters like 32 billion, 14 billion, and even 7, 3, and 1.5 billion. So this is actually helpful for use. So if you have like a laptop which has only 8 GB of RAM, no graphic card, so you will actually be able to run Qwen 2.5, 1.5 model, 3 billion, 7 billion, and so on based on your hardware. And if you have a graphic card, you can even go for 14 billion one and 32 billion one. So this was the brief introduction about the models and how you can load them and easy. So once you have download them, you will easily be able to navigate them from here. So here you can see all the models are already downloaded, and we can actually explore them into the file explorer. So here is all my models from different vendors. So for example, if I go to Onslaught, I have already downloaded these models from the Onslaught. So this was all about how we can search models and then download them. So now let's move forward to how we can load them and actually use them for our task. So in order to load the models, go to this section, which is select a model to load. And here you can see the list of models in your machine which you have downloaded. Now, let's start with the very basics one. I will actually organize them from the side. And let's run the first model, which is this DeepSeek's R1 with the 8 billion parameters. And in order to run, just click on it and it will actually ask you for different parameters, which will be by default selected. So here, if you have a GPU, it will select automatically the layers your GPU will be able to handle. So in my case, since the 4 GB model, we have like 8 GB of the graphic card. So the model will fully be able to run in our GPU. And here you can select CPU threads based on your hardware. And next you just click on load, and it will take a few seconds to load the model. And once the model is loaded, you can actually see in your task manager that if the model is loaded into GPU or just RAM. So here, if I see my GPU 0, which is my NVIDIA GPU, the model is actually loaded into the dedicated GPU memory of my graphic card. So this means the model is fully running into our graphic card. So now test the models with some basics prompts. So as a very easy prompt, I have just asked him to explain Google Earth Engine and Gmap to me to see if it actually understand it or not. So one of the good thing about DeepSeek is we actually can see how the model is thinking and connecting different relationship. So now if we see the thoughts of the model, we can actually see that the model is not able to identify what is Google Earth Engine and what is Gmap, because here we can see the model is not familiar with them. But after this thoughtful analysis, it is able to just give us a basic definitions of both, which is actually fine. So now we will give it a more complex prompt to see if it is actually be able to create some code for Google Earth Engine, and we can actually check them if the code works or not. So as a basic code, as a basic prompt, I will actually ask the model to generate and visualize NDVI. So here I have simply asked the models to generate a code to visualize NDVI for any of its choice region using the Landsat 8 dataset. So let's see if it is able to identify and write the code. So here we can see some concepts like NDVI, it has identified them completely correct, but overall it does not understand what Google Earth Engine is and how to write its code. So for example, here we can say it has completely hallucinated the code, and actually it has written something related to GDOL, which is directly not relevant to what we ask in the prompt. So this means that this DeepSeek model is more focused toward general queries, like if we want to explain something or some codes or formulas, it will be able to do that. But generating code from scratch, especially the subdomain like Google Earth Engine, it is not very able, especially the 8 billion model. So now we will just confirm this with a more complex model like 32 or maybe 14 billion to see if those models are able to identify Google Earth Engine or not. So in order to run some other model, you have to first eject this model from the memory. And once ejected, you can go again here and just search for your model. So previously we run the 8 billion model which fit our memory, and now we can run the 14 billion model. So here you can actually see that by default, it has selected 27 layers to be offloaded to GPU. This means that the model will not be able to fully offload into our memory. So let's load this model and see its performance. Now the model is loaded. So for the comparison, I will create a new chat, and here I will ask him first to briefly explain Google Earth Engine and GPM to me. So now it actually take quite a lot of time to generate, and we are seeing a reduced token counts. For example, previously we were getting around 30 tokens per second, and now the rate is 4.5 token per second. And it has actually given more detailed results compared to our previous test with the 8 billion parameter model. But if we look into the thoughts of this model, it is not actually able to identify at first which is GEE or GMAP, and based on deduction, it has concluded this. So let's run our second prompt to generate a code to visualize NDVI for a region. Okay, so here we can see that the code took more time than our last prompt and run with 14 tokens per second. But now this time with the 14 billion model, we are actually able to get the syntax correct. For example, the Earth Engine API used here is quite great. There are some issues like we don't need to authenticate or initialize the Earth Engine JavaScript like this way. But overall, the codes look fine. Let's test this code into a Google Earth Engine editor. So here we can see that after some debugging, we are able to get the results in the area. So it has actually visualized the NDVI collection for us, and we are able to get the visualization. So a few issues that I observed in the code were, so first of all, it initialized search engine, which is not needed. Then there are some random text. I don't know why in the chart. So I removed the chart completely. And lastly, I think the information it used to train is based on the old guides and information. So, for example, previous Landsat collections works with the B5 and B4, but the new naming is like surface reflectance band 5. So here I just modified them to SRBF5 and the code run. So overall, this means that the model is actually able to handle the code, knows the syntax, and if you give it any kind of your Earth Engine code, it will be able to interpret it and then guide you further or maybe identify problems with it. And the best part of this model is that it is actually only around 8 GB or a 9 GB model. So this means even if you don't have a graphic card, you can easily run this model into your RAM and can compute different things with it. So this was the DeepSeek comparison between the 14 billion and the 8 billion. Obviously, you can go further up to the 32 billion model of the DeepSeek, and the results will greatly improve. But obviously, this was creating like 4 tokens, so we will get very low performance with those models. But this overall idea gave us a general overview. Okay, so the DeepSeek 14 billion model and above are actually able to understand the GE syntax, but still have some issues in creating the code. So this means we can actually go for some models which are more code specific. So for example, Qwen 2.5 model is more of a model which understand and can interpret code. So let's load and test the Qwen model. So as you can see, I have now loaded the Qwen 2.5 coder, which is code specific model with 14 billion parameters into my GPU. And let's run our first command, which is to explain Google Earth Engine and Gmap. So now we are able to get our results with around 3.7 token per second, but actually it identify all the information correctly. And one of the drawbacks actually is we were not able to get how is the model thinking like in the case of DeepSeek, but overall we get the result. So now we will input our second prompt to generate the code and see if it can actually generate the code or not. So I'll just paste the code and see how it runs. So here we can see that we get our results, and comparatively it take a lot more time compared to the DeepSeek version. But actually when we look at the syntax, the Google Earth Engine API, it is very good compared to the previous one. So let's see if actually it runs or not. So we'll just paste this code again into our code editor, and we'll just click on run. Okay, so here we can see that the code actually runs without any issue. So one thing that I just changed was changing the collection from 1 to 2 because one has been removed from the Earth Engine dataset library. So only the 2 is available. Beside this, the code completely understands the syntax and generated as a NDVI for California, which we can see right here. So overall, we can see a clear difference between the existing code specific models, which perform better in code specific application. But for general query or general question answer session, the DeepSeek obviously can be a little better with the ability to run models on a lower end machine. Lastly, we will just quickly test the 32 billion model and see if it performs any better than the 14 billion model. And we will actually give it a more complex prompt and see its results. Okay, so we can see that our Qwen 2.5 32 billion parameters model is loaded into our memory. Since this model was greater than the GPU memory, it is using both GPU and the RAM at the same time. Okay, so for our next prompt, I am actually using this bullets which says that create a script that lowers the elevation datasets, then calculate slope and aspect, then add a hill shade for visualization, and lastly use a map center to zoom, which the previous code also zoom in fine. And lastly, the main point is the script should run without requiring any user input. So let's see if it actually can calculate elevation, slope, and aspect with this 32 billion model, and how is the result compared to the previous one. Okay, so we can see that the results of 32 billion model is completed, and it was the slowest with only 1.46 token per second of the code generation. And yeah, the overall code logic seems good. So let's run and test this code if it works or not. And here we can see that the code completely runs without requiring any kind of user input, and all the layers are computed and visualized. So we can see the shaded relief, as well as we can see the hill shade, the aspect, the slope, and the elevation in the study area, which is computed just fine. So this was the comparison between different kind of models that we can run locally. So in this way, you can run different kind of models locally, and you can select based on your need. For example, for my use case, if I'm working generally or want to search something or write something, the DeepSeek 8 billion or 14 billion model is good. But if you want the code specific model, I think Qwen 2.5 has the capacity to generate codes without minimal error, and especially in terms of debugging, if you already have written some code, you can just copy and paste into your Qwen model, and it will actually be able to identify the issues or suggest any potential changes. Again, it all depends on your end user hardware. So if you have like only a laptop with only RAM, I highly suggest you start and test the DeepSeek 8 billion model, which you will easily run, and then move forward based on your need. Similarly, while these models are accessible, open source, and have open new avenues for different kind of application, so this was all for this video. In this video, we have seen that how we can download and run LLM models locally, and especially their performance for Google Earth Engine related application and code. So this was all for today's video. See you in the next one.